Hi my friends, today we model this interesting assembly which is called double crank mechanism, and I want you to notice that the moving translation stops 3 times, which is important in some cases. This is the mechanism. You see there are some components here, and we want to place all of them to obtain the mechanism. All these are components of this mechanism. If you are interested to create the spur gears, I recommend you to take a look and watch my tutorials number 143 and 287. Components are made with Inventor 2014, and you can download all of them if you have at least the journeyman level in the membership. After this overview, let's start building the assembly. New standard millimeters IAM. Place. We place the main component, stand DCM, grounded at origin, and as you can see, here is a plane which is not useful here, so I go to this and I apply visibility. Again, we have to rotate this because now we work with the Inventor 2024 and not 2014. Set current view as home, and we have the proper position. I want to apply edges, shaded with edges, to have a better look. Good. We add the spur gear, which is an assembly, as you can see. These two are an assembly, and I told you how can you create this assembly. Open, place here, and constrain. We constrain with the insert this circle axis to be placed here. Circle axis. Okay, now we can rotate all of this together. They are not flexible, you see. We place now this point on this axis. Apply. If I make this flexible, we have a surprise. The surprise is that you can move this along. Control Z, and we apply measure M from Monaco between these two faces. 13.5 is the distance. We use this distance to constrain with the flush 13.5 between this face and this face. Okay. Now we can rotate without problem this assembly, mobile assembly. Control Z. I place it in the first position. Then we add some other components like main shaft. This is main shaft with keyways. This one is the smaller, which are in 2 number. Then the other one only once. We place, this is bigger, it comes here. Constraint, insert this axis circle or arc and this. You see, it is reverted. Apply. Then mate of this face to be placed on this face. Okay. Apply. We go now to the other keys. This one with the same constraint. Apply, and this face comes to this face. I rotate it, you see. The last one is this one to be placed here. Apply, and you see I can rotate this if I select this end, not this end. Constraint this face with this face. Apply. Good. I place this shaft inside this hole. Constraint. I select insert and I place this face on this face with a line. Okay. Now you can see that we can rotate this and nothing happens to the spur gear. To see inside, I select the stand and I make it not visible. Then, considering this to be fixed, I rotate this until we see the internal key, this one. We apply constraint of this, first this, and the second this. The shaft was rotated to be in a proper position. See? Now I make visible again that stand. I have to eliminate to make not visible this, and we have a consistent combination now. Now you know that we used here a lot of keys and keyways to make this correctly from the point of view of mechanics. But especially I use now a shaft without any key to see that we can use in 3D modeling also without keys. Place shaft 1646, which is without keyway. You see? No keyway. Good. And what we do with this? Constrain, insert, aligned this face and circle on this face and circle. Apply. Now we can apply constraints between work planes of the two objects. This is one, this is another. This object has this plane or this plane to be selected. Let me select this one. The other one is the component of the spur gears, and I suppose is this one. Let me see. Yes, I select this plane or this plane. I select this one. Yes. Now this shaft is oriented in position with the spur gear. Take a look. You see, they are rotating together. Good. I close this to have space here for other components. More than this, I can apply constraint of angle. First solution, 0 degrees between this edge oriented to the right and one from here oriented to the right. For instance, this one. Now there was a small rotation here, but we have a starting point well known for all of us. Okay, we add now other components like the crank DCM twice, and also T shaft also twice. Constrain, insert this T shaft, apply, and the other T shaft, apply. We maintain this constraint to place this circle axis over this circle axis. Okay or not okay? Let me see here. I'm not sure, so I don't apply, and again constrain insert this. We must be sure of each step. Yes, it was okay. This is the place. Apply. Now we rotate this crank until we see the key inside. Here is the key. Constraint, mate this face with this face. Apply. We continue with inserting this circle axis here. Apply. Let's make the same procedure to find where is the key. Here is the key. Constraint, face on face. Okay. We add now some important components. Lever twice, and T lever once, and the slider once. Let's place the slider in its position. This face to be on this face. Apply. This threaded hole is only on one face, and this is the correct face. Then we apply contact between this face and this face. Okay, apply. We use insert to place this lever here, apply, and the other lever right here, apply. We connect this T lever using the same constraint. This comes here, apply, and this goes here, apply. Now we have connected all of them, almost all of them. We apply constraint of this axis over this axis, or point is enough to apply on a point. The other arm is of course in position as well. We add now some shafts. Place shaft 97 to be placed aligned insert with this aligned. Okay. Good. Other components are the two short shaft, these ones, 1, 2. Constrain, insert, aligned this face to this hole, apply this face to this hole. Okay, they are placed here, even if we don't need them when we make such a simulation. Now we go right to the animation. Everything is placed. Oh, not all components are here. Let me place the other. Place this two kind of rings, 2 and other 2, smaller and larger. These are called Ziegler safety rings or circlips. You know them, I suppose. Constrain, insert this circle to be placed on the greater shaft here. You see what we have here. Apply. The other one on the other side. And this one which goes right here. Good. You see, it is here. Apply. The other two goes here. Apply. And on the other side, which means right here. Okay, now we have the final assembly. We know that we have an angle to this shaft. Click on it and we identify which one is. I go here, but let me tell you something. If you want to see what is this, you can use find, or you can use the keyboard end, the key end on the keyboard, and you see what is that part. Yes, but now we are looking to this. We open it, we apply drive, we place here 4 times 360 degrees, and I place it in position, start. You see how it works with that 3 stops. 1, 2, 3. This is interesting. Yes? and back to see again the movement, the animation. Very nice. You see? Okay. Now comes an interesting topic. What I present here is based on the existence of the components that appear in the assembly. Regarding this modeling, you have two options. One, to contemplate what I do and apply my actions by creating your own components of this assembly. And two, try to create the assembly using the actual components you see in the tutorial. If you want to create this assembly independently, you must own the component. That is, they must be yours. As separate creations that I made for the purpose of showing practical aspects in the tutorial, you can download the components only from assets. Access to assets is done by subscribing minimum to the level Journeyman membership. You see here the levels of membership: Core, Journeyman, Patron, Professional. Excepting Core, the other ones includes the previous ones. That's all for today. Thanks for watching. Bye bye.